Shawty heart is on steroids cause her love is so strong. You may fall in love when you meet her. If you get the chance, you better keep her.
Juicy J!
Break her heart, she turns cold as a freezer. That fairy tale ending with a knight in shiny armor. She can be my sleeping beauty. I'm gonna put her in a coma. Damn, I think I love her. Shawty so bad.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever with part 3 of the cross product, the vector product of two vectors. Oh, love me some Juicy J. All right, so this video is pretty short. We're going to find out what all this nonsense is about. It's just some explanation of some things. So we got an issue here. Let's say I have the cross product I cross J. Okay. Well, that cross product, let's say it's equal to the vector k, that goes in this direction. But how do you know that it doesn't go down? Because we know that the result of a cross product is a vector perpendicular to the original two vectors. So going straight up is perpendicular, but also is going straight down. So how do you know the direction? Huh? How do you know it's not going down? Well, I will tell you that J cross I is equal to negative K. In other words, that vector is going down. That's weird. So how do you tell the difference? Well, it's determined by something that is called the right-hand rule. The right-hand rule. And I'm going to show you a video here from the YouTube. You like the YouTube? All the kids love it. Okay, so here I have blue vector A and green vector B. And right, if you're looking at it now, it kind of looks like B is going straight up, but don't think of it like that. It's actually flat. Think of this as like a street intersection that we're looking down on. And blue is a street going this way, and green is a street going the other way. Like you could go straight or make a left-hand turn. It's not coming up. See if you can get your eyes to see that, okay? So now we're going to have a hand coming in. Here comes the hand. Here it comes. Okay. And so I stopped the video, right? And the hand is going in the direction of the first vector, vector A. It's going in the direction of vector A. And then it's going to, the fingers are going to wrap towards vector B. Watch. These fingers are going to wrap around towards vector B. Watch, it's awesome. Okay, and now the thumb is going to rise in the direction of the cross product. The cross product of A cross B is C. Vector C is the vector that's the result of the cross product. And that's the direction, the red vector, and then you can kind of see the end result. That's called the right-hand rule, okay? So if you think about it, if you think about the hand coming this way and then wrapping this way, the thumb goes up, okay? Here's another example of if I have a vector A going this way and the hand, sometimes there's some explanations where it's just a finger that goes the other way, but the hand is wrapping around this way. The thumb goes up, that's vector A and B. And this is kind of weird because you have to sort of think of your, the hand is upside down now because this is J cross I. So if you think of your right hand going this way, if it's facing up, see if I can draw a thumb. Like, you know, you're thinking, well, wait a second, Mr. Becker. Here's a hand. Oh, that's horrible. Here's a hand. Oh my gosh, it looks like a shark. Okay, there's the thumb. I'm so embarrassed. But this is J cross I. Okay, so how do you figure that one out? Let's get rid of that hand first of all. Okay, so I'm going to pull this one out and I'm going to turn this guy upside down and hopefully, let me see if I can do that. You'll be able to see why it's going down, right? So it's J cross I. So if you look, so A is going this way, right? This is A cross B, this one, right? So it's J cross I, so the forefinger or the entire hand is going this way, and then you wrap the hand towards I, and then it goes straight down. It goes straight down. Okay. I think I know what the problem was. I was thinking of a left hand instead of a right hand. If the hand I drew is right-handed, the wrap would go that way, and it's not possible unless you have some sort of freaky hand for it to go this way. Okay. So the right hand rule is a way that we can use to find the direction, which way the cross product vector is going. Okay. What about the length of A cross B? Okay. So here's A cross B, which is a vector, right? And we know how to take the magnitude of a vector. It's each component squared. Yes? Another form of this that is useful is the magnitude of A cross B equals mag A, mag B, sine theta, where sine theta is the angle between A and B. And that should look very familiar to the rule, the relationship we have with the dot product. And in fact, one way to derive this, this relationship is using the dot product. But here's another nice little proof that I'm not going to go through. It's very clear. If you really want to know, you can follow it very, very easily and see this relationship. And the immediate consequences of this result are, if U is a unit vector in the direction of A cross B, right? So let's just think about that. So we have A, yes. Here, well, let's go back here so I don't mess this up. Let's do this. So let's undo that. So we have A, and then we have B. Okay, so this is A, right? And this, oh, that looks like a Q because I'm not using my pen. I was using the mouse. Sorry about that. So here's A, vector A, and here's vector B. Yes, and so then the cross product is going to be a vector. Let's make it blue, going this way. Right hand rule wraps this way. Thumb goes up. There we go. So that's A cross B right there. Let's make that blue just to make things A cross B. Okay. So if U is a unit vector in the direction of A cross B, so let's just say that this is a unit vector in the same direction, right? So it has a magnitude of 1. Then A cross B is equal to mag A, mag B times sine theta multiplied by that unit vector U. And some people that say that this is the geometric definition of the cross product. Also, if A and B are non-zero vectors, then A cross B equals 0 if and only if A is parallel to B, which makes sense because if I have A parallel to B, I can't form a plane, right? I can't form a plane. So the definition is that it's perpendicular to both vectors that form a plane. Okay. So no examples, just a little bit of chat about vectors and the cross products. That is the final cross product video. I know that you enjoyed it. I know you enjoyed yourself some Juicy J, some KDP. So we will go out with them. I am like a dark horse.